Okay, so you're just going to have some basic problems to try to find the derivative of. So if you'll look, some of those are inside parentheses, some of those are fractions, some of those are under a radical. What are the two things I don't like? Fractions and radicals. Okay. All right, so the one thing that I want to go and do is I want to do number 5. I think we did number 4. Number 4 got a little intense. Go back and find your notes. Let's look at number 5. Find the coordinates of the point. Find the what? Coordinates. Oh, I think we did 5 already. Yeah, let's look at 6. I'm sorry. Let's look at 6. Find the equation of the tangent. I don't think we've done this, or have we done this one? Number 6.
Yes, we did 6 and 7.
All right. Okay. So go back and look at these. I was going to work those, but go back and look at these in your notes. So basically what we did is we took the derivative, found the slope at x equals -1 or x equals 13, found the y minus y1 equals slope x minus x1. Okay, so we're good on that one. Other ones to possibly try if you want to work would be page 180, number 7 through 9. Try those. Check your answers in the back of the book. Okay. Again, it's just using U substitution. I don't think we did number 10. Okay, so let's look at number 10. Given that f of x equals 1 over 1 plus x squared, find f prime of 2, and then b is the value of x such that f prime of x equals 0. Now, one of the things that I'm going to start getting you to do on these little assessments that you take after the video is explaining in words what that's telling you to do. Do not necessarily work it, but explain in words. So explain to me in words what f prime of 2 is telling you to do. That's half true. F prime is the derivative. So you have to find the derivative first. Again, salt and sugar. This is f of x. Okay? If you're struggling now, don't worry. I'm going to really, really, really work hard to get this to where you see it. This is f of x. This is f prime of x. They are not the same thing. So I have to first find the derivative and then plug in x is 2. So that's how I would want you to answer a question like that. Now, I don't like radicals and I don't like fractions, so I'm going to rewrite this as 1 plus x to the negative 2. To the negative 1. This whole thing is grouped to the unseen first power. Now, I want to use U substitution because I have grouping here. So, excuse me, U equals 1 plus x squared. So that means y equals U to the negative 1. Now, you should be getting fairly proficient at this chain rule. du dx equals 2x dy du equals, Lordy mercy, So dy du equals negative 1 u to the negative 2. So I'm looking for dy dx, which means I do my road map, dy du times du dx. See how I label everything. This isn't just because I like it. It keeps me knowing where I'm going. My dy du is this. My du is dx is that. So negative 1 times 2 is negative 2x. And then my u was 1 plus x squared to the negative 2. Now, that's what you're going to have to do on several of the problems. That's it. There's going to be no related rate. It's just going to be finding the derivative. You will have them under radicals. You will have them in denominators. In denominators under radicals. Now, it said last f prime of 2. So you take your calculator out and store 2 as x. I think it's negative 4 over 25. I think so too, but I'm not sure. It works.
Earlier I said instead of waiting on the bells to ring 3 minutes late, they just need to go over the intercom and go,
Get Miss Kathy to do that. Okay, so comments or questions about this one? A part. Yes, sir.
So is that a viable format to leave it in at the end, or do you want to change it to the F in apostrophe of 2 equals?
yeah.
Either way is okay.
So you can just leave it as dy over dx.
I don't really recall any of the particular questions fussing that you don't, because it's just going to be A, and it's going to have a grouping, and they're going to look for an answer.
But if you put it as like what you have written next to A there, equals negative 4 over 25.
That's perfectly okay. All right, comments or questions about A part? All right, can I erase it so I can keep everything up here and look at the B part question? Is everybody okay if I erase it? Y'all can all, this will be up here for you too over the weekend if you want to go back and look at it. Woo. Okay, so it says the value of x. So this time I'm looking for x. Guys, again, you are going to learn this. It may take some of you a little longer than others, but you're learning to read this. So tell me what this is asking for in sentence form, or what you're going to do.
What is x when y is 0 in the derivative of the f of x?
What is x when the
Derivative.
derivative is equal to 0? So if you can read it that way, what is x when the, look at this, it tells you, what is that representative of? The derivative is equal to 0. Now, did I just find the derivative? That's the reason I didn't erase it. Did I just find the derivative? So now I'm solving for x. They did not give me an x. They like these questions a lot, by the way. Now, the one thing I will tell you is when I'm solving for x, I don't like negative exponents. I do like fractions. Because you're going to see how easy this really is. So what is the derivative equal to? 0. So I'm going to put 0 there. Do you see? If you're trying to memorize it, again, you're going to hear me say this 1,000 times between now and May. If you're trying to remember and trying to memorize it, you will forget. Read it. The derivative, this little thing right here, is equal to 0. I'm going to set it equal to 0. Now, when I'm solving for x, I hate negative exponents. And you cannot, listen to me, this is not negative 2x times 1 to the negative 2 plus x to the negative 4. It is not that. You cannot take this and distribute. No. No, 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 no. So get that out of your head. One thing I am going to do is now I'm going to turn it back into a fraction. Watch me. The algebra, if anything, is what's going to get you. This is not to that negative power. Do you see that? It stays in the numerator. That's how this is rewritten with a positive exponent. I take the one thing that is to the negative power and I flip it. If it's in the numerator, it goes to the denominator. And as soon as I flip it, it becomes positive. Because see, it was negative. It wasn't happy where it was. It wanted to move. So as soon as I move it, it became positive. Y'all back already? They're over there. Just leave it kind of cracked, Chris, when you leave, okay? So, how do you always and forever get rid of a denominator? Multiply. What happens when you multiply it by 0? It's 0. Now, what if they said this was 1? You multiply it by 1. Don't make the assumption that I just set the numerator equal to 0. No, that's not what I said. If I multiply this on this side to get rid of it here, and I multiply it on this side by 0, it becomes 0. So what is the value of x? 0. All right, talk to me. These are where I like questions.
Can you just complete the square on that instead of differentiate? Because you know that it's saying that 0 is the slope of x at a certain point, and if it's a quadratic, because it only has x to the second, couldn't you just complete the square and find the vertex?
It's technically not a quadratic because that positive square is in the denominator.
Oh, okay, I got you.
On a question like that, will you sometimes get like multiple answers?
You can, absolutely. You could end up, they might say, what are the possible values of x? And you would have a quadratic, more than likely, and then you would use your polysolve.
But it wouldn't be in the vertex.
Okay? All right, good. Other questions? Anything about the mechanics of what I did? My steps. Can you go from here to here, changing that negative exponent back to a positive? Okay. All right, no comments or questions? Not quite right yet. I'll give you one in a minute. All right. Turn to page 184. We're going to work one or two more, and then I'll give you a break. Again, you can practice number 1, 2, 3 on your own. Check your answers in the back of the book if you want to get practice with differentiation. Have we done number 4 that anybody can tell me? Because I've lost track. We did do number 4? Okay. We didn't do 5, though, I don't think. All right, let's look at 5. Given that y equals the square root of x cubed plus 1, show that the derivative is greater than 0. In other words, it's what? It's positive for x is greater than negative 1.
What?
Okay, I'm going to walk you through it. So what you're going to do is you're going to show me that the derivative is positive for all values of x greater than negative 1. So I need to do what? If you saw this problem, what do I need to do first? Take what?
Take it out of the radical.
All right. How would I rewrite it? X cubed plus 1 to the power of, all right, then what do I need to do? Oh, hey, Max, have a seat, honey. So Max came in. We were recording this for you, Max. But now Max is in.
All right, now, Frank's the only one who can ask a question.
Can I say hi to yourself?
Okay. What? So that's great, but what did I do that in anticipation of doing? Taking the derivative. Do I need to use u substitution or no? So my u is what? All right, and my y now becomes so my du dx is 3x squared. My dy du is 1/2 u to the negative 1/2. I'll give you a minute to process that and write it down. You're over there. Right here, I'm pointing right down. So my dy dx is equal to my dy du times du dx. I'm going to say 1/2 times 3x squared is 3/2 x squared times my u.
How do you do the show that?
All right, this is how I'm going to do the show that. It's going to be pretty simple.
It's asking pretty much for like to prove the range in a given domain. Right?
So it says greater than negative 1, so let's pick a 1. Take out your calculator. Hmm? 0, because you're going to have 0 in the numerator, it's going to be 0. That's just not a good one to test. So store 1 as x and then type in the derivative. And tell me what you got. which is positive. Correct? Now, I might just go and show that like at 2. I get 2, right? Which is positive. Now, what I might do, just for the sake of argument, is I might put in -2, just to show that the negative doesn't work, doesn't give me a positive. I got a domain error. So now I might try to see if a -3 would work. I think I'm still going to get a domain error. Yep. You've got that radical in the denominator. So the other thing that I can do to prove, everybody look up here. So that doesn't hurt. Let me show you this. Would you agree that it is that? What is x greater than -1 mean? Tell me what that stands for. That is my what? That's my domain. X is your domain, right? What can your denominator? Your denominator, we said, has to be greater than 0, correct? Some of y'all are falling off. You're not paying attention. X is your domain. So we know to get the domain, I have 2 restrictions on the domain. What are they? X under a radical, X in the denominator. So the restrictions on my domain all have to do with radicals and denominators. And I have both. Why didn't I put equal to here? The denominator could be equal to 0, and I can't have that. So I'm going to divide by 2. Would y'all agree? Get 0. Square it. Get 0. I'm solving for x. What? Move 1 to the other side. Cube root. What's the cube? That makes a -1. What's the cube root of a -1? Did I just prove that? My domain. Did I just prove my domain?
What would you use for that first? The 2 square roots of x cubed plus 1. Where did you get that?
From the denominator of my derivative. I took that and just rewrote it like that.
So you can prove it one or two ways.
Okay, so you can prove it 1 or 2 ways, or you
Yeah.
have to prove both components
No.
to maintain the domain.
They probably prefer this, but I think you would get some points for doing this.
The thing is, like, if you plug in 0 to your
You're going to get 0.
which is it's not greater than 0.
It's neither positive nor negative, too. So
So
greater
does
than
that satisfy it or not? If it's because it says it
If 0 times
says
2
that
is
dy
0,
over dx is greater than 0, but 0 is not greater than 0.
yeah. I know that's the part that's.
So as long as it's not less than 0, it's fine.
So right here, this technically is the proof that they won't. But you will get some credit if you can't remember this and at least do this.
Now, what again did you do to take it from that derivative that we found to the one right there?
Okay, everything that was raised to the negative gets moved to the denominator. So the 3x squared stayed. The 2's already in the denominator. I just moved this down there with it.
Yeah, it took me a second to process that. Why was there a 2 there?
This is already in the denominator. You don't have multiple denominators. Technically, you're not supposed to. You're not supposed to have fractions within fractions. So if you have a fraction, this one stays in the numerator. Everything else goes in the denominator with the 2.
Yeah, it just took me a second to get there.
All right, other questions, comments about this one? All right, let's work number 7, and then we'll take a break. 7 says find the equation of a tangent. So I'm going to write a big tangent right here. And then I'm going to write point and slope. Because an equation, I'll require 2 things, a point and a slope. Y equals 4x plus 3 to the 5th at the point negative 1/2 1, given your answer in y equals mx plus c format. Okay, I'm going to read to you how I interpret this. So, like if I was able to read Spanish, I would read Spanish and interpret it in English. I can read math, and I can try to interpret it for you. So, if they want an equation of a tangent, equation means I need a point and a slope, correct? Do I have either one of those? I have what? The point. Now, the slope, when I think of slope, I need to immediately translate that to derivative. Now, the derivative is the slope of the what? Slope of the tangent. It's the slope of the tangent. So what happens here is you have some function and you're wanting to know the slope at that point, negative 1/2 1. So I want to know the slope of the tangent. The derivative is always the slope of the tangent. So that means I need to do what to find the slope? Differentiate. Take the derivative. So that's going to be y equals u to the 5th, u equals 4x plus 3. So dy du equals 5u to the 4th, du dx equals 4. So the dy dx equals dy du times du dx.
We have to label like the dy du and the du dx and stuff.
I don't want a 4 stuck out there. I don't want 5u to the 4 stuck out there. I want to know what that is. Now let me state that again. I need a slope. In calculus, when you need a slope, you need to think derivative. And it's the slope of the tangent. So how in the world does this help me find slope? The
That's
20.
your slope formula.
That's your slope formula.
Just plug in the x.
What do I need here to get the dy dx? What do I need? What is the letter here? X. Do I have an x given? Negative 1/2. So you're going to store negative 1/2. So that's 2, no, yeah, that's negative 2 plus 3, 1. Is it 20? 20. That's my slope. This, everybody, is the slope of the tangent. Right there. Is it not 20?
Yes.
20, did you,
4, -1/2, -2 plus 3.
so how do you write equation of a line? What's the first thing? What's the first format? Y, point slope. Y minus y1 equals my slope, x minus x1. Now, can I stop? Am I done? I've written an equation of a line. Guys, I'm going to count off points. They want it in this format. What do I do to go from point slope to slope intercept? What's the first step? Distribute. Now, do you hear what I'm asking you to do? I'm asking you to carry on a conversation. I was told by people who've gone through graduate classes, medical school, dental school, that one of the best ways to study is to have a conversation, which is why I'm really wanting y'all to explain to me in writing and to talk to me. So if you can have a conversation with somebody and say, yes, to go from point slope, I distribute. And then I move my Y1 over. If you can carry on a conversation and tell somebody in words how to do that, you can more than likely do it yourself. I'm going to tell you, taking notes is great, but if you don't understand it, doesn't help you get very far. Yes, sir.
So I understood up until I understood you getting the slope of 20.
The 20.
Based on the derivatives of
Right.
the road map. And I used a different way of getting the final answer. I just sort of pictured the graph of it being.
Did you get what I got?
Please, all football players need to report to the Commons for their pregame meal. Thank you.
I think so, yeah.
He probably just used the
Sorry,
negative
I
1/2 and
wouldn't
added half
You
to the
started going
slope.
on that, and I was just like, wait, stop what you're doing. But I was on that path.
That's fine. That's fine. I'm gonna have to really pay attention to the mark scheme about whether. I don't think they have to see this because you could technically put in the M, the Y, and the X and solve for C.
That was what I was on the way to doing.
Yeah, you can do that too. Yes.
I have no idea where you got that other stuff.
All right, I distributed the 20. 20 times X is 20X. 20 times 1/2 is 10.
But where did you get the X plus 1? Oh, that's the point.
That's the point slope. Y minus Y1
Y minus Y1
equals your slope,
or
X minus X1.
Okay. I always have trouble remembering that. So
But
yeah,
if you want to plug in your Y, X, and your M and solve for your C, that's okay too.
I'm trying to have both tools in my box.
Well,
Just always have to
Yeah.
do it.
because the one thing is if they ask for this equation and you don't remember it, that's a problem.
You're right.
Okay, questions about number 7. All right, y'all go ahead and take a break.